Hello guys, welcome to the online learning of the subject Kinematics and Theory of Machine. Now before learning any subject, it is very important to understand that why do we learn the subject? What are the reasons that the subject has been introduced in mechanical engineering? Now the term kinematics deals with many things like mechanism of anything that we are used to use or see in our day-to-day life. Say for the example, the mechanism of the arm-like structure of JCB, mechanism of chain and sprocket in our bikes or bicycles, mechanism of opening the door, or mechanism of anything. Kinematics also deals with the term motion of every mechanism. Now most of the time, the reason behind to understand the motion is many times to understand the range of the motion, which means, say for the example, if I open the door, how would I know that how much area it will cover? Let us also consider the case of JCB. Imagine the front arm of the JCB. What will be the range of operation of that arm? From how far the JCB will be able to dig. Like this, there are many more terms that will be introduced in this subject, like velocity of the motion, acceleration of the motion. You will learn these terms in the subject later on. As of now, let us see what things have been covered in your syllabus as a whole, like cams, belt, rope and chain drive, friction, clutches and brake, gears and gear trains. Now, few things from this are relevant to theory of machines, which I'll teach you later on as a part of this curriculum. Now let us start our studies with the chapter friction. The reason behind starting from this chapter is we all are much familiar with the term friction. Let me tell you that we all come across some things which is directly or indirectly relevant with the friction. Without friction, our life is impossible. Yes, you heard it right. Without friction, we are not able to walk. Friction between the surface of road or surface of anything that we are walking on and the surface of the sole of our shoes. If friction is not present, we may fall. It is the friction only with the use of which we are able to drive our cars, because of the friction between tires and road. If some of you knows how to skate, you must know that how do we start skating? We push one of the legs, with the help of which our another leg starts skating. Now think, without friction, are we able to push? Now it is unarguably true that without friction, we are not able to apply the brakes. We also write because of the friction. Yes, friction between the pen and the paper. Okay, so we have seen enough examples of friction, and we all are agree that without friction, our life is impossible. But to better study the friction, it is necessary to bifurcate that. Means we have to study the friction in parts, because the friction with the help of which we walk on the road and we drive our cars and bikes on the road is not the same as the friction responsible for writing on paper. In other words, friction between tire and road is not the same as friction between pen and paper. How we can categorize them? Majorly, let us start with the two major categories of friction, that is static friction and dynamic friction. To better understand the difference between these two types of friction, let us watch a video. In this video, a woman is pushing the sofa on a rough carpeted surface. Did you notice something? Let us watch it again and focus on the friction between sofa and the carpet. Now at this point, the woman is applying much force but the sofa is not moving. And after increasing the force, the sofa starts moving. Let us watch it again in slow motion. You can clearly see that the woman is applying much force but the sofa is not moving. In other words, it remains stationary or static. Simply, this is the static friction. The friction responsible for not letting the object move. So, you can say that static friction is the friction between two stationary objects. In our case, it is the carpet and the sofa. It should be also noted over here that momentum is also playing some role over here, but we are not focusing on that as of now. Currently, we are only interested in friction, that is responsible for not letting move the objects which are stationary. So again, static friction is the friction between two stationary objects, and dynamic friction is the friction between two moving objects. In our case, when the sofa starts moving, it is dynamic friction between sofa and the carpet. So you can now clearly say that static friction is the friction between two stationary objects and dynamic friction is the friction between two moving objects. Now these two friction, static friction and dynamic friction, can also further be classified. Dynamic friction can be classified as sliding friction, rolling friction and pivot friction. The example of a woman pushing the sofa over the carpet was the example of sliding friction. Any object rolling over any surface is an example of rolling friction. The mirror of our two-wheelers is an example of pivot friction. The joint with the help of which you are able to adjust your mirror is named as pivot joint, and the friction between that surface is called the pivot friction. Friction also can be classified according to the lubrication applied, means non-lubricated and lubricated. Lubrication is the process of lubricating any surface to reduce the friction to avoid the wear of the surface. The friction because of the dry surface is called the dry or solid friction, and the friction because of the lubricated surface is called boundary friction, and another category is fluid friction or viscous friction. Now, as we have understood that what is friction and also have gone through few categories of the friction, means the classification of the friction, let us move towards learning and understanding some laws of the friction. First, let us understand laws of static friction. There are many laws of static friction. Let us go through one by one. Force of friction always acts in opposite direction of which the body tends to move, which means frictional force always acts opposite to the direction of motion. If you are pushing some object towards north, the friction will always act south. If you are pushing an object towards right, the frictional force will act towards left. As you can see in this image, the person is pulling the object towards left the frictional force is acting right. Next law says that magnitude of friction force is exactly equal to applied force, which tend to move the body. Which means if you are pulling or pushing something, the friction force is exactly equal to the amount of force applied by you. Now, to understand next law of static friction, you need to understand what is normal reaction. To understand it better, let us go through an image. Normal reaction is the force that is exerted by the surface on which the object is in contact with. Means, if you are standing on the floor is also applying the equal amount of force, means the floor also applies the force equal to your weight. Normal reaction always acts in perpendicular direction to the surface on which the object is in contact with. As you can see in this image, if the surface is inclined, the normal reaction is perpendicular to the inclined surface. So now you have understood what is normal reaction. Let us move towards the next law of static friction, which states that magnitude of limiting friction bears the constant ratio to normal reaction between two surfaces. Now don't worry if you don't understand what is limiting friction. I will teach you that later on in subsequent videos. So limiting friction bears the constant ratio. It means the value of friction F to the value of normal reaction R is equal to constant. Simple. So this is the third law of static friction. Now let us move towards the final law of static friction, which states that force of friction is independent of area of contact between two surfaces. Yes, that is true. No matter how large the object in size is, the friction has nothing to do with that. Let us imagine the scenario. As you can see in this image, there are three objects on same surface. Object 1 is large in area, object 2 is smaller than object 1, and third object is the smallest one. Now this experiment was actually conducted by someone, which proved that the frictional force is independent of the surface area, which means it doesn't matter how large or small the object is, frictional force acting will be independent of the area of the object which is in the contact of the surface. Hope you have understood what is friction, few categories of friction means classification of the friction, and laws of static friction. We will continue our further curriculum in next subsequent videos. Thank you.